Guys and girls, it's know it time! Hey, let's get crack-lacking! It's know it time! Know it time!
Alright, let's start. So today, I'm going to be teaching you about trig. I want to go back to grade 4. So back in grade 4, every one of you were taught something called, how to use something called a protractor. Now, that protractor, you probably use it once or twice in your entire life so far. You never ever touch it again. Yep, it's so true. And every single year, the stores advertise it. You gotta have your kids, buy those rulers that comes with a protractor. But you think those are actually a waste of money. No one uses those. And they're expensive, but you use it once or twice in your whole entire life. The whole purpose of that is to measure degrees. See, a protractor, we know, measures degrees. So let's write down degrees. Degrees is an unit of measurement for angles. Okay? That's what degrees really is. Now, I'm going to mix elementary school with high school now. You were taught how to draw a quadrant, 4 pieces. This we call quadrant 1. Quadrant 2 lies right here. Quadrant 3 lies right here. Quadrant 4 lies right there. Basic concepts, nothing too bad. Now, again, before I can start trig with you, I have to teach you a lot of vocabs. We're going to draw quadrants again. I'm going to show you something called a line. Okay, and there's a specific name for this line. I'm going to highlight 2 arms for you. This arm right here is called the initial arm. Initial arm. Okay. This blue arm I'm going to highlight. This is called the terminating arm. Terminating. Wait. Sorry, Jason? What? Didn't you say something back there? I have no idea what you said. Terminating arm. Okay. So again, 2 concepts. One is the yellow arm. The yellow arm is always stationary. That's it. That's your initial arm. You can't change it. No. Only your x-axis right here. Always the initial arm. No exceptions to this rule. Nope. Always, no matter. Your terminating arm. Nope. It's always this arm right here. This arm can move around. This arm can move around. Can move. Okay. The initiating arm, or my initial arm, this will always be the same. There's no exceptions to this rule. Will always be the same. Now, if you really like what I'm teaching you for trig, take pre-calc 12. You're going to spend 2 months doing it, and this is what they focus on in university a lot. This will always be the same. Okay. Some people actually think Math 12 pre-calc is is easier than Math 12 foundations. There's no logic. You guys actually learn logic about stats, and that's where people fail the most. See, this arm can move. This arm has speeds. Now, one thing, there's an angle between the 2. This is called theta. So I'm going to write a few things down. Theta is the angle between the 2 arms. That's what theta is. It's the angle. Circle with a line through it. Yep, that's called theta. Theta is the angle. Now, normally in grade 8, grade 9, you guys use the term x. But in senior levels, there's no more such thing as x. When we say an angle, we call that theta. Okay. Now, we can take a protractor and we can measure this. Guys, gals, if I were to ask you to take a protractor and measure theta, I want you to take a guess. I know you don't have a protractor with you. This is all a guess now. 50, 45, doesn't matter really. Some of you say 45, some of you say 50. See, all these are actually correct. And notice the unit I'm using? I'm using degrees. Degrees. So that's what a protractor does. It teaches you the concept of degrees. Without the protractor, a lot of you say, huh? What? Where? I want you to draw the draw this for me. If I say theta equals to 290 degrees. I'm going to pause my recording, walk around. Let's see, where is the terminal arm going to be? Draw it. Idris, what quadrant are you in? Quadrant 4 is correct. Now, if you're working with this here is 0 degrees. This is 90. This is 180. This is 270. These are the basic ones you got to work with. So 290 really is going to be, again, I play the guessing game. There's my, go back to this, see, initial arm, terminal arm. Now I'm going to show 290 like this. We're going to draw something called a snail trail from here all the way to here. See, it shows you that my arm has rotated that way. And this, we know is going to be theta. And in this case is 290 degrees. You have to draw this trail. There's a reason why I asked you to draw the trail. Guys, gals, I want you to try this. Okay. A. So let's try this one. Theta equals to, I'm going to make it a bit more challenging this time, since you know what to do. Now, I'm going to grab your smartphones out. We're going to vote on the answer. Okay? No, not super. No, we are going to vote on the answer. So grab your smartphone out, load up my app. I'm going to pause it while you guys load it. Recording again. Here is your question. Theta, let's see if we can get this one correct, equals to 4, nope, not a super note. I just want to see where the class is going to vote. See how many can get this correct. Without talking to your friends, let's see if I can get this. 420 degrees. A, I'm in quadrant 1. B, I'm in quadrant 2. C, I'm in quadrant 3. D, I'm in quadrant 4. Guys, gals, let the voting begin. 420 degrees. What quadrant would I be in? Guys, gals, so take a minute. I want you guys to vote. Good luck. I'm going to walk around, and so right off the bat, I see 2 people voted A. I'm going to walk around, and let's see what the class would vote on. I'm going to pause. I see 10 people voted for A. 1 person voted for D. 1 voted for B. Now, I'm not sure who's right and who's wrong, so let's, right off the bat, let's draw a quadrant right now. Okay. 420 degrees. If I go all the way around, would you agree? 360. But I'm at 420, so really, I'm looking for 60 degrees. Because if I go all the way from here to here, now read, settle down. I'm at 360. But I want 420, so 60 degrees is just a bit more. So this is why we need our trail. I call this my snail trail, because it looked like a snail shell. Yeah. Because if I go all the way up to here, I'm at 360, but I have 420 to go. So this is how we work with degrees. And again, guys, gals, my answer is 60 degrees. All of you who said A, congratulations. No. There's no E. So, guys, gals, congratulations to everyone who said A. That is correct. See, that is easy because you're used to working with degrees. Now, in Math 12, guess what? There's no degrees. Angles can be measured in degrees. This is what you did in grade 4. Nothing new, nothing tricky. Or here is where the new stuff kicks in. I'm going to teach you a new unit. This one will answer a lot of questions on your calculator. Radians. I'm pretty sure none of you have seen this yet, so this is now a good time to teach you what radians. See, if I go to Subway, I order a 6-inch sub. Okay? What? But what? See, I can also work as centimeters. See, both of these are units. They're the same thing. They're just different units to measurement. Same concept with degrees and radians. They are all units to measure something. So I'm going to show you conversion. By the way, does anyone know the unit conversion? Oh, you're pretty good. 1 inch equals to about 2.54 cm. That is correct. Now, if you're ever stuck and say, Mr. How big is an inch? On average, this is a normal average person. Look at your index finger. The first notch from the top of your index finger to the first line, the average person, that's roughly a perfect inch right there. That's an inch. If you have your ruler, you can actually measure right now. It should be about 2.54. Okay? That is an inch. That is an inch. So if you're ever walking around and say, oh, how big is that? This is it. This is 1 inch. Okay. Now, if you have a ruler, you can actually try it right now. See if you have the average human finger. But I want to go from degrees. No, I'm saying the average person. Everyone's going to be different. Degrees to radians. So there's always a conversion from degrees to radians. This is not as simple as 1 degree equals something radians. Here's how you do this. 180 degrees. You need to know this right now. Are you guys perfect or no? Yeah. Oh, you are the perfect human being? So 180 degrees equals to something called pi radians. Now this is going to be confusing. Pi, we know is 3.14. 3.14, that's what pi is. So 180 degrees actually represents 3.14. But I'm going to use pi, it makes it a lot easier for you guys. So if I ask you this, to convert from degrees, pi radians, because radians unit, from degrees Yep. 180 degrees is actually pi radians, or 3.14 radians. To convert from degrees to radians, you're going to remember this. Multiply your question by 1 fraction. Okay. And this is my best advice I can give you. Multiply your question by 1 fraction. So here's what it is. I'm going to give you, your fraction is this. I'm going to use these two numbers right now, 180 and pi. So you can either have 180 over pi, or if you have taken Chem 11, this would be very familiar. This is called stoichiometry. Anyone taken Chem 11 yet? Yeah. There's a term in Chem 11 or Chem 12 called stoichiometry. How many heard of that term before? No? Yeah? So you actually use it if you have taken it as, or pi over 180. See, look what I did. I just took these two numbers. I just made it a fraction. I either put this over this or this over that. Now, people ask me, so how do you know which fraction to use? Here's the best advice I can give you. Whatever unit you want, that goes on top. Units you want, that unit must go on top. must go on top. Okay. One sentence that will either make you or break you in this chapter. This is it right there. Whatever unit you want, the unit must go on top. So if I give you an example, I want 45 degrees. By the way, if you're planning to go to college and university, there's no such thing as degrees more. They all work in radians. Why? Because radians is a much more complex form. See, 45 degrees. Every one of you can imagine that easily. I have no doubt about it. But I'm not working with degrees. I want you to practice using radians. How many radians is 45 degrees? So I'm going to pause it and let you try this out on your own. Show me the work when I come around. So guys, let's read what I just wrote. It says to convert from degrees to radians, multiply your question by one fraction. So my question was 45 degrees. Right off the bat, I'm going to go 45 times. Now I have to multiply by, this is where Chem 12, Chem 11 kicks in, stoichiometry. I have to multiply by one of these fractions. It's just a matter of choosing the right one. Lavraj, which one are you going to choose and why? Why are you choosing this one? Exactly. See, I want in radians, so radian has to go on top. Pi is a symbol of radians. So I go pi.
You have to do degree sign?
No, you could. You want over 180. No. It depends on what you want to convert from to where. Okay. So if I look at this now, degrees, yes, stoichiometry cancels out. So really, what you get is 45 pi over 180, which I want you to simplify this. Leave your answer as a fraction. You can write this as pi over something very nicely. It goes very nice. Pi over 4. Or some may say, Mr. No, I don't like it as a fraction. I'm going to write it as decimal. You have to be able to go from here, because on your exam, I'm going to show you this. Sometimes they may only give you this as an answer choice, and you have to see where it came from. Because 45 and 180 cancels out. No, you have a calculator. Pi over 4. Take pi, divide by 4 right now in your calculator. Where would I get a 4? Because simplify 45 and 180 cancels out, leaving you with what at the bottom? 4. Okay. 45 pi divided by what?
Divided by 180.
Yeah, same thing. You get points. But I'm saying this on your exam, they can have this answer only. You should be able to tell me how you go from here to here. Okay. It's just calculation work from there. So guys, gals, this is how I convert. Just like if I give you centimeters and I want you to convert to inches, we do the same formats. You should be able to figure out on your own. Right. Grab your cell phones out. I want to see if you vote on this one. Hi. I have pi by 6. Is this degrees or radians, first of all? How do you know? Hang on. Amber, degrees or radians, first of all? This one, right? This question. Is this a symbol for degrees or radians? How do you know? Because the pi. The moment you see pi, that's the symbol of radians right off the bat. See, this is radians. Somebody must know, I hate radians. I love degrees. Guys and gals, tell me what degrees you're in, and I want you to vote A, quadrant 1, B, quadrant 2, C, quadrant 3. Hang on, I'm going to clear the thing. D, quadrant 4, and please don't horse around and vote E. Seriously, guys, you're more mature than that now. I want you to vote A, B, C, or D. I'm going to clear all this up. Main screen. Multiple choice. Guys and gals, vote for your answer. I want pi by 6. Some of you say, Mr. No, I can't work with radians. Convert it to degrees and tell me what it is in. My first vote is A. I don't know if that person is right. I'm going to pause it and I'll walk around, but I'll leave. Guys, from the results voting, a lot of people are voting A. So if you're lost and say, Mr. No, where are these people getting their answers from? Let's show you how to do this right now. See, right off the bat, Some of you are not used to working with radians, so I'm going to convert. I take my question, pi by 6, times, okay? Amit, what am I going to multiply this by? I know, but times by what? What fraction? Is it 180 over pi or pi over 180? 180 over pi. So look what happens to the pi. Oh, look at this. Pi's cancel out. So you're left with 180 over 6. 180 over 6 gives you 30 degrees. So really, this is now 30 degrees. Guys, gals, 30 degrees. If I draw the right quadrant, exactly what we've been practicing earlier, you should be in quadrant 1. Congratulations to everyone who voted A. You guys got it right. Okay? So this is how this is done. Okay? You can work with radians just like centimeters and inches. There's no difference. It's just saying potato, potato. Wheat, french fries, and ends. I think that is it. Actually, I'm going to give you one last one. Sometimes they don't give it to you in using pies. They give you 8.1 radians. Okay? Notice the pi is gone. They're going to give you decimal this time. I want you to tell me what is your degree and what quadrant are you in. So I'm going to clear the voting thing again. So let's clear the main screen. Vote for your answer, please. Quadrant 1. A is quadrant 1. B, quadrant 2. C, quadrant 3. D, quadrant 4. Guys, gals, take a minute. I want you to vote. I'm going to pause it. Majority of you are voting for B. Okay, we're going to figure out who's right, who's wrong. Right off the bat, I'm going to start with simple. I take 8.1. Multiply. Jason, what fraction are you going to multiply this by? See, I wanted to make it degrees. So I take 180 over pi. Now some of you say, Mr. No, where's pi? In this case, there's no pi, so they can't cancel out. So this is what we're going to do. So it'll be 8.1 times 180 divided by pi. Grab your calculator right now and let's do this. Let's see what the answer is going to be. So 8.1 times 180. Divide this by... Yeah, you could. I like to do this slow so people can see where they are. 464 degrees. So really, this is 464 degrees. Okay. Now, 464 degrees, the next question lies, what quadrant is that? See, if I go up to here, that's 360. So if I go minus 360, let's see what I really have. Minus 360. What I'm really looking for is 104 degrees. So 104 degrees, again, I played a guessing game. Lies right around here, maybe. That is how we work with radians. Everything you're going to do from now on is just degrees or radians. There's no difference between the two. It's just different measures of units. Guys, gals, that is your work. Congratulations to everyone who said B. Your answer is correct. Your work for today. That's it. Was it that hard? No, not really. 180 over pi. Yep. Page. 519. Numero 1, 2, 4, 5, 6. Not today, because there's nothing in the gym. 8. That's it, guys. 1, 2, 4, 5, 6, If I can come up with a question, I'll give to you. Hi.
I would think you said about Friday, you're gonna bring the list.
Hi. Good. Yeah, I had to listen. You know my car accident. The guy rammed your list, and then yeah, I had to listen to my hand. Except the guy hit my car, and I dropped your list. Good point. I'll give you a listen in a second. Guys, that is your lesson for today.